Good evening, everyone. Today, I'm going to talk about the use of process migration to capture my live malware. Before I begin, I'd like to briefly tell you about company. About our company. FFRI was established in 2007. Yuji Ukai is Chief Executive Officer. He's also a member of Black Hat Review Board. Our main business is producing endpoint security software for zero-day protection using heuristic-based approach. It's over. Also, allow me to introduce myself. I'm Yosuke Chubach. Chubach is my family name. It's a very unusual name in Japan. Please call me Chubach or Bach. I'm an engineer at FFRI Incorporated in Tokyo, Japan. I've been a PhD student of the University of Tsukuba for 3 years, but still no PhD degree. I never give up my degree. My main research interest is system security, like an access controls for operating system, such as mandatory access control-based sandbox. Also, virtual machine-based malware prevention system too. Do you know Bitvisor? No? Oh, I said. My research lab produced a hypervisor for academic project. The hypervisor enhanced guest OS security by single instance VM like McAfee DeepSafe. Also, Bitvisor provides device IO mediation framework with Syn hypervisor. Now, Bitvisor version is 1.4 available. Also, I completed a national human resource development program called Security Camp in 2005. Today, I'm a lecturer in this program since 2011. I teach OS-supported sandboxing techniques in Linux and Windows to high school student and bachelor student. So I'd like to also say that I'm a member of the SecCon Executive Committee. We organized the largest capture the flag event in Japan. My task in SecCon, server operations and an audit system development. We'll be holding an online capture the flag event next December. So please join us. You are interested. If you win the online event, we will invite to you with travel support. This image is a visualization of King of the Hill in the SecCon Final 2013. What do you think this? Do you know Ghost in the Shell? Oh, okay. Many Japanese hackers like cyberpunk animation. I'm also one of them. So now I would like to move on to our main subject. Here's an overview of today's presentation. First, we'll take a closer look at sophisticated modern malware. After that, I'll describe the idea of capturing live malware and its challenges. Then I'll illustrate the implementation of our system called Sweet Spot, and give a demonstration of capturing with Sweet Spot. So today, malware is the Swiss Army knife of cybercrime, cyber espionage, and cyber war. As you know, today's malware is armed with many analysis techniques, just one after the another. This is a problem because we have to prevent the malicious behavior of unknown malware, and we have to prepare next attack. So we really want to know the malware's true intention, victim organization too. What's the real purpose? What's the real target? We have to force the malware to give up its secret. For example, Citadel is malware that targets online banking. It can detect the execution environment and does not engage in malicious behavior when the current host differs from the infected host. The purpose of this behavior is to avert analysis, both manual and automatic, like sandbox analysis. Here, I'd like to introduce Citadel's analysis techniques. First, I'll discuss host fingerprinting, and second, virtual machine and sandbox detection. This is a diagram of host fingerprinting. Citadel installs itself by self-rewriting using a unique value for the victim host. This value is set when the host is infected by the original version of Citadel. Environment-sensitive Citadel and the original have different binary patterns. Once installed, Citadel runs on only the infected host. This environment-sensitive behavior uses the value of the disk's globally unique identifier. So it's called DGUID. It compares the DUID value of the executing host and the embedded GUID value of the infected host. This shows exposure of GUID when after unpacking. Okay, let's move on to the next point. Some variants of Citadel are armed with VM and sandbox detection. For example, Citadel searches for VM and sandbox related artifacts for environmental awareness. Artifact refers to specific resources like the VMware tools process and the virtual device in VirtualBox. Perhaps some artifacts are live malware's binaries, pop-up killer, and stimulator. Is this perhaps it is malware's binary. After VM detection, Citadel might present decoy behavior if it senses an analysis environment. For example, to terminate its own process. Sometimes executing dummy behaviors to mimic Benid software, like to connect Google website. So, in my opinion, sophisticated malware activity can be classified into 3 phases. Here, the breakdown. First, the initialization phase. Second, the scouting phase. Final, the malicious behavior phase. I assume that scouting code is executed before the main malicious behavior, main malicious routine. So I also assume that the infected host, the infection does not cause serious problem if the malware is executing anti-analysis behavior. As I mentioned before, we really want to know about the malicious routine. So the initialization phase and the scouting phase doesn't matter. So it's a main idea. I assume that a security analyst or incident handler will make most observations of malicious activity after migrating the malware process from the infected host to an analysis environment when dealing with anti-analysis behavior. So process migration is the most important keyword of my presentation. So I'd like to show you two use cases. The first is capture of the live malware. In this case, the end user executes a suspicious executor file. Then the capture system will suspend the program if it detects anti-analysis behavior. Many malware analysts focus instead on malicious activities. The second use case is an advanced honeypot. The honeypot fakes an artifact of the target host. The way the system deceives the malware is like cyber espionage. So next, I want to talk about process migration. Process migration is really hard. Why? Because it has to migrate the process along with execution contexts, memory contexts, persistent contexts, and related kernel objects. And execution environment sensitivity is also a big problem in process migration. By the way, do you know about virtual machine migration? Virtualization is a sophisticated means of process migration. As you know, cloud computing is a large-scale version of VM, and it allows resource productivity through migration. Commodity hypervisor supports OS migration and its live migration. But VM migration to many resources are migrated, which hinders malware analysis. Also, VM solution forces end user and employer to implement an additional system. This increases complexity, decreases maintenance-ability, and raises cost. Now, we have a solution for lightweight process migration. We use a process-level sandbox. If we carefully think about the process migration, we can see that a CPU emulator-based sandbox is the most convenient and suitable environment for malware analysis. A CPU emulator-based sandbox grabs all needed context for process migration. This is convenient for migration because sandbox has virtualized processes with related kernel objects. Please look at this figure. Processes on bare metal OS completely environment dependent. But a CPU emulator-based sandbox provides an equivalent environment for every host. So it is my main idea. CPU emulator-based sandbox grabs enough context of migration. Also, the sandbox provides equivalent environment for every host. In addition, a sandbox is a good tool for malware analysis because all malicious activity confines in the sandbox. Okay, let's talk about malware freeze drying. It's main topic of my presentation. End users runs malware in the sandbox. The sandbox suspends target program when a trigger event occurs. Now, a suspended trigger is anti-analyzing behavior. In my idea, another sandbox in analyzers hosts defrost packed live malware. First, defrost sandbox receive packed malware within executable file, memory image, and some context. Next, the defrost unpacks malware and restores all context for process resuming. Finally, defroster reconstructs the address gap between freeze dryer sandbox and defroster sandbox. So it's completely restart to malware. Okay, I did it. But migrated malware will probably execute anti-analyzing continuously. So what the hell? My system absolutely needed to fight against anti-sandbox. So therefore, I was forced to update my challenges. I will try to fight against anti-sandbox. Hey, let's move on to the next point. Here, I'd like to introduce anti-sandbox techniques. But many great prior works exist on this topic. In this session, I sought these researches. And I show the point of CPU emulator-based anti-sandbox techniques. In addition, I'll present this topic at PACSEC 2014 next December. Next November. Please check this conference if you are most interested in this topic. This shows a taxonomy of anti-sandbox techniques. First, I introduce anti-sandbox maneuver. Second, I show sandbox detection, including debug and virtual machine detections. First, stalling code. Stalling code technique is wasteful loop before malicious behavior. The purpose of such evasive code is to delay the execution of malware activity long enough so that automatic analysis systems give up upon the sample. This code is a sample of stalling code. It refers to a paper of Corbish's at SCM CCS 2011. This helper function performed to avoid busy loop. The code waits for to stop sandbox analysis. Fortunately, starting code detection and mitigation already proposed in this paper. I follow it. This slide shows environment awareness of malware. It is the checks of the host environment. If malware detects and analyzes sign, runs with decoy routine. A typical example of that would be the host fingerprinting of Citadel. Decoy routine means malicious behavior hiding. For example, environment-aware malware access to dummy connection over the internet when it detects VM error backdoor port. And as I mentioned before, environment-aware malware uses sandbox and VM detection. These detection techniques can classify three approaches. First, artifact fingerprinting. Malware will find VM and sandbox-related resources. Second, execution inconclusiveness. In other words, timing attack. Third, platform stimulation. I will tell you about in detail of these approaches. Artifact fingerprinting is the check of VM and sandbox-related resources. As I mentioned before, Citadel's anti-VM activity. I cannot show all concrete artifacts because a wide variety of artifacts exist, each hypervisor and sandbox. But the striking aspect of artifact fingerprinting, these artifacts are additional resource. So if we want to deceive malware, we hide some artifact from malware process. Okay, let's go to next. Execution inconclusiveness is measuring some timings and the values of execution environment. Please have a look at this figure. The code shows the compare timestamp counters value between two timings. It's a traditional anti-debugging technique, but it also detects environment on virtual machine. The striking aspects of execution inconclusiveness that timing attacks is less robustness than artifact fingerprinting. So the less robustness. Finally, I introduce platform stimulation. Here, I'd like to introduce related prior research. In last Unix security, very interesting research was published. Cardinal pit testing is discovered CPU emulation differentials. If we want to more detail, please read this paper. The striking aspect of platform stimulation, it's trade-off of emulator implementation quality and emulator performance and development cost. Okay, in this research, I will concentrate on solving the first approach. My system has API proxies for disable malware into fake target resources. To avoid unsandbox behavior, our system hides sandbox-related artifact using this mechanism. Up to here, I have spoken about concept. Now, let me move on to implementations. Our honeypot system using process migration called Sweet Spot. Sweet Spot consists of two sandbox. First, freeze drying sandbox and two defrost sandbox. Freeze dryer runs on end user's host. If it detects anti-sandbox behavior, it suspends the target process and preparing for process migration. It's here. So defrost runs in the analyzer's environment. So let me describe our IA32 CPU emulator. I have already a CPU emulator-based sandbox for Win32 execution in-house use in my company. It's used for prototyping. The sandbox likes IDA box B operation mode. It's extremely primitive emulation for CPU execution cycle. Instruction fetch and decode and resolving addresses and execution. Hardware assistance do not use at all. So all execution contexts are kept on user and memory of sandbox. It's very important. So the sandbox grabs many process contexts. Anyway, all execution contexts are kept on user and memory of sandbox process. And the sandbox emulates some Windows APIs. For example, if a target process called create file API, virtualized resource manager provides a virtual file system in the sandbox. So registry also virtualized. This shows a virtualization object of our CPU emulator. Currently, GUI interaction virtualization and media component and the network virtualization is not supported. So let me explain the design of Sweet Spot. Freeze dryer serialize all process contexts and executable files if detected suspended trigger. Defroster restores all processes contexts from serialized data. At the same time, defroster reconstructs address mapping. So in addition, defroster approximates some API calls for deceive malware. Okay, it's freeze dryer overview. End user can use like an antivirus software file scanner. So freeze dryer serialize process context if detect anti-sandbox behavior occurred. In addition, I use the message pack library for serialization. It is convenient for C and C data serialization. It's developed from Japan. Currently, suspend trigger defines some API call. Number of API is listed. Get volume information, get volume name for mount point, quiz file, open file, and open leg key. I will try to detect starting code in near in the future, but not implemented yet. So this is the sequence of the Frost live malware. First, the Frost unpacked all process contexts. Next, all contexts are allocated in the sandboxes heap area. Second, loading executable file, and the Frost runs ploader before code execution. At the same time, the Frost reconstruct address mapping. So the sandbox has the mappings of between virtual address at sandbox and the process's virtual address. So migrated process context hold freeze dryer's allocated address. So it is so different. After reconstruction, the first resumes migration process from suspended instruction. Okay, thank you for waiting. So I show some demonstration. This is a simple program. It is difficult to see, but this code is 10 times count program from 0 to 9. Also, the one integer value is allocated on heap. So the value is 11. This program, if the count value equals 5, suspicious API call unexpectedly get volume name for volume mount point. So don't care. Okay, look at this movie. So first, I have some sample program on vanilla environment. This program count up 9 from 0. It's here. Also, the last value is 11. It's on heap. Second, I ran this program on freeze dryer. Okay. As you know, freeze dryer is sandbox. In this version, API proxy invokes upon sandbox processes printf function. So this is in the sandbox. So look at attentivity. So stopped the count on 5, and the freeze drying is started, and packed this program. Okay, I shall call this the code again. Now the program suspended at underlying the code. Okay, the next the defroster incoming. It's a defroster's view. This is analyzer's environments. You can see that the volume level different from freeze dryer. Sorry, this is very small. So defroster resuming the sample code program. Hey, come on. Okay, I did it. So it's achieved process migration. So it's called process resuming after the count of 5. The defroster resuming from 6 and to 11. It varies on heap, so the process migration with and the heap area. Okay. Now I'd like to move on to the next subject. API proxies provides virtual resources and freeze dryer environment artifact. So I'm sorry, this mechanism is work in progress. So okay, next. API proxies have the saving possibilities for anti sandboxes and cyber espionage. First, the Froster performs play innocent with sandbox and VM related artifact. Second, for faking artifact. Today I chose a demonstration of to disable VMware detection on our system. So this code snippet is the VMware detection functions is written by C code. First, VMware sysfile1 function called getFileAttribute with the path of vmmouse.sys the system driver. And second, VMware regkey2 function called regopenKey with VMware tool sign. Yeah, this is test run of this code. This program runs count up to 10 with sleep on bare metal host. Here, it is on bare metal host. So 10 times of print 1. So on VMware, this program embeds count up routine. So okay. So it is on the VMware host. So the detector of VMware and not appeared 10 count. So running with freeze layer, okay, it's captured. So let's go to run captured programs on analyzer's environment. Of course, this is on VMware. So let's start. Okay, start. Defrost start with packed this program. Okay, this program brings back to life. So the 10 times print 1. So okay, by the way, I should apologize to you today. I cannot show demonstration of real malware capturing because our system can run limited individuals of data array only. So I cannot prepare a suitable sample for a number of reasons. Sorry. Next, I show limitation honestly. Currently, sweet spot is immature. It have many limitations. But I will remove the limitation in the future. For example, so cannot complete emulation with SA instructions and cannot create process and create thread. So the process management is not virtualized. Uh, okay, I try to solve issues of sweet spot. So in particular, storing code detection and evasion is most interest issues for me. So okay. Wrap up. We propose concept to malware migration for anti-analysis and to make advanced honeypot. This is proof of concept of malware capturing using process migration with CPU emulator-based sandbox. We were able to confirm from some concept programs that our system can migrate, process, and resume it. Okay, so it's over. Thank you for listening to my talk today.